Hi, I'm Bob. Welcome back to 5 Minute Econometrics, a program dedicated to fundamental econometric concepts, estimation methods, and identification strategies. Today, we will explore a test for functional form misspecification, known as the Ramsey Regression Specification Error Test, or simply the reset. As a test for functional form misspecification, the idea behind reset is that if the linear regression model is the true relationship between x and y, then any nonlinear terms, such as the quadratic or cubic terms of x, should be statistically insignificant when they are added to the original model. Recall that the OLS fit value is a linear function of all the explanatory variables. The squared fit value and the cubic fit value contain quadratic and cubic terms of all the explanatory variables and their interaction terms. So, we include them in the auxiliary regression in the reset test. The null hypothesis of the reset is that there is no functional form misspecification. That is, delta 1 and delta 2 in the auxiliary model are both 0. If we reject the null hypothesis, there is evidence that the original model is misspecified in its functional form. It may miss some important nonlinearities. If we fail to reject the null hypothesis, we should not worry about functional form misspecification. There are two steps of the reset test for functional form misspecification. In the first step, we estimate the original model using OLS and obtain the fit value. We then compute the square and cubic terms of the fit value. In the second step, we run the expanded regression or the auxiliary regression. We add the square and cubic terms of the fit values to the original model and test whether those two new variables are statistically significant. We will test three models for their functional forms using reset in Stata. The model relates hourly wages to education and age. We first use the level term of hourly wage as the outcome variable. After OLS estimation, we follow the two steps to perform the reset. We use the predict command with the XP option to store the fit value, H wage hat. After generating the square term and the cubic term of H wage hat, we add them to the original model and perform an F test for the joint significance of the two new variables. The F statistic is 19.89 and its p-value is 0 to at least 4 decimal places. We reject the null hypothesis of no functional form misspecification. In other words, it is strong evidence of functional form misspecification. It suggests a misspecified functional form of the original model. Next, we use the logarithmic form of hourly wage as the outcome variable. We do the reset again. The F statistic becomes smaller, 4.97, and its p-value is 0.007. It provides weaker evidence of functional form misspecification, but we can still reject the null hypothesis of no misspecification at any significance level above 0.7%. Finally, we add the square terms of schooling and age to the model. The F statistic for the reset becomes even smaller, 1.37, and its p-value is 0.26. We fail to reject the null hypothesis at any significance levels below 26%, including the conventional 1, 5, and 10% significance levels. In other words, the coefficients of the quadratic term and the cubic term of the fit values are both 0. The original model does not suffer from functional form misspecification. In terms of functional form, this model is the best of the three. The reset is a test for detecting the general type of functional form misspecification. If we reject the null hypothesis, the model is misspecified in its functional form. We should consider modifying the model by using logarithms or adding a square or interaction term. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.